All right, looking at these alternative energy sources in food, right? We eat a lot more than just sugar. And if all you ate was sugar, you probably would not last very long. Okay. So we break down complex carbohydrates, fats, proteins, and we can use these types of things in these processes as well. With glucose metabolism, it's a lot more straightforward. The glucose jumps right back in, it splits up, and it goes through this process. With these other ones, we have to use other enzymes, split it into different forms. And so we can still run cellular respiration with things like fats and proteins. So what we see here is with complex carbs, things like starches, we can break these down into glucose, our other simple sugars, and then break those down into pyruvate, go into glycolysis, piece of cake. When we consume fats, right, there's a lot of energy stored here for us to take advantage of. We can take the glycerol head, split it off from those fatty acid tails. Then that glycerol with this enzyme can go through glycolysis and make pyruvate. Those fatty acids get picked up by our coenzyme A, and they can go directly into the Krebs cycle. Our proteins can get broken up, and it really depends on what amino acids are there specifically. So some amino acids can split up and turn right into pyruvate. Some can jump right into the Krebs cycle. Some are intermediates within that Krebs cycle. Okay, so if we need to use these other sources for energy, our body is equipped to do that. Okay, so here we see starch, these chains of sugars. So what we need to do is we just need to break it down into the monosaccharide sugars, and then boom, we can use those for energy. Okay, so we break down the starches, other carbs, to their monosaccharide units, turn them into glucose 6-phosphate, which continues in glycolysis. Okay, so we modify these into glucose and then go through glycolysis and then the rest of the process. Okay, something that our cells will do, if we have a lot of glucose already in our cells, then we don't need to continue breaking this down and turning it into energy, into ATP, if we already have that ATP there. So what we're going to do is we're going to take this glucose and we're going to form our own complex carbohydrate known as glycogen in animals. So we're going to put all of these glucoses together, form glycogen, and that's kind of an energy storage for us, so that when that ATP starts running low, we'll take that glycogen back, break it down into glucose, put it through these processes to make more ATP. So here we have our fat, our glycerol head, which we break off. That can go be modified directly into pyruvate, go through glycolysis. Then our fatty acid tails, these chains will be modified and go into the Krebs cycle. And in between each of these bonds, there's a lot of energy. Okay, so we've got a lot of energy stored in fats. Compared to carbohydrates, fatty acid breakdown yields more ATP per carbon atom. Okay, so there's a lot of energy stored here, which is why when we have too high of a blood glucose, that acetyl-CoA goes away from the Krebs cycle into a pathway to make fatty acids. So when these levels are too high, we've got too much of this glucose, we start producing these fatty acids, and that's how we put on things like fat in our body. And so here we have a specific amino acid, which looks very similar to pyruvate. Basically, this nitrate group is going to break off and take on an oxygen, and then it's pyruvate right there. Now, some amino acids have a different R group down here, and so they're going to go through a slightly different process in order to enter cellular respiration. Okay. Again, depends on the amino acid to what's going to happen, how they're going to be processed for energy. And that is the end of cellular respiration.